Welcome back. This is Mr. Greenstein's Geometry. We're in Chapter 4, Transformations, and we're talking about rotations. So here's a perfect example of a rotation. We have a very artful way of writing the band's name, Aerosmith, and they were popular back in the 1970s and 1980s. And if you rotate this around, you'll see that it still spells Aerosmith in the same way. So a very, very creative way of using graphics and rotation. So rotation, the definition, is a transformation in which a figure is turned about a point, a fixed point. And the fixed point in this particular case is the center of rotation. And it's going to be turned around that point a certain number of degrees so that it always stays the same distance. So R is always going to stay the same distance from P in each case, and Q is going to stay the same distance from P, Q and Q prime. But they're all going to go the same angle. When you're farther away from the center of rotation, you go a farther distance, and that's why R looks like it's a lot farther from R prime than Q is to Q prime. The strict definition is that every point stays the same distance from the center, and the angle of rotation is the same. So we have 40 degrees, we have 40 degrees out here. So those are the two things that have to hold. Let's check this out. This first one, you can see it's not a rotation. In fact, it looks more like a reflection. Let's just pick a point and say that this is the center of rotation. And if I choose this point and this point, you'll see that they're the same distance, so it passes that test, and then we have this angle here. If I connect two other points, so here's the before and here's the after, and then I draw the angle, you'll see that the angle is much different than the first angle, so they're not getting rotated in the same way. Therefore, this is not a rotation. Let's test this. In some ways, if we don't look at it too carefully, it could look like a rotation, but in fact it's not. And we'll put a point here and say that this is the center of rotation. And then we're going to pick the before and the after points. So we have a before point here, and we have an after point here, and then we have our angle. We can pick another point and put that to the center of rotation, and this is the after, and you can see that the angle is not the same. It's actually a little bit bigger. So this is not a rotation because it doesn't follow both rules. The distances are the same, but the angles are not the same. Finally, for C, this one is actually a rotation. So if I pick a point like here as a center of rotation, then I can see that the before and the after, so here's the before and here's the after and here's the angle, that one stands out well. And then we have, let's choose another one. So we'll choose this point and this point here and the angle there. And the angles are the same. So with every point, the angles are the same and the distance is the same. Therefore, it is a rotation. So rotating about the origin, rotating 90 degrees, we have some rules that make life a lot easier if we're just handed xy coordinates. So if the xy coordinates are a, comma, b, then we just take them, and rotating 90 degrees, it's negative b, comma, a. And rotating 90 degrees, we're talking about a clockwise, or counterclockwise, counterclockwise motion. So 90 degrees is counterclockwise, 180 degrees counterclockwise, 270 degrees counterclockwise. This one is for 90 degrees. For 180 degrees, we take the xy coordinates a and b, and we just negate them. Negative a and negative b. So we take this coordinate and just negate it, and that puts us in a place that's exactly 180 degrees about the origin. And then rotating 270 degrees, that's just a, b, and we just convert that to b, comma, minus a. So then that's 270 degrees around the origin. Let's actually try this out. We have a pre-image where I have 3, 1, and we'll call that R. And then we have S, which is 5, 1, T, which is 5, negative 3, and U, which is 2, negative 1. And we connect these together, and we get a figure that looks like this. And we want to rotate 270 degrees around the origin. So 270 degrees around the origin is this rule. A, comma, B goes to B, comma, minus A. All we do is just plug in the numbers. So we have 3, comma, 1, and 3, comma, 1 will just become 1, comma, minus 3. So if I do 1, comma, minus 3, and I end up down here, and that's where my new R is going to be, my R prime. And I should write that in a different color. Let's do that. So this is my R prime. And then 5, comma, 1. I'm going to change that to 1, comma, negative 5. So 1, comma, negative 5, 1, 2, 3, 4, 5. Then that becomes the new S, S prime. I can do this with T, 5, comma, minus 3 becomes negative 3, negative 5. So negative 3, 1, 2, 3, 4, 5. That becomes the new T. And then finally 2, comma, negative 1 turns into negative 1, negative 2. Negative 1, negative 2. And that becomes my new U prime. So I connect these together and I get my new figure that's rotated 270 degrees from here to here. Much easier using rules than anything else. And we'll continue this conversation in the next video.